Hello, this is question 4 on your November 2021 paper from AQA. It's paper 1. You have ABC is a trapezium where A is the point 1 minus 2, B is the point 7,1, and C is the point 3,4. DC is parallel to AB, AD is perpendicular to AB, and we have to find the equation of line CD. So I'm going to do a quick sketch so we find ourselves a bit. If not, I find it a bit difficult. So we have something like this. A is somewhere here, and is the point 1 minus 2. B is somewhere here, and is the point 7,1. And C is, let's say, here, and is the point 3,4. And then, so we have a trapezium that is these 2 points together. Then this line is perpendicular, and this line is parallel. So it's going to be something like this, roughly. Yeah, it's not, the drawing is not great, but it's helping us to find. So this is perpendicular, and these two lines are parallel, right? So we have to find the equation of the line CD. And this point is D. CD. We know this is parallel to this one, so it's going to have the same gradient, and it's going to pass the point C. So first of all, we are going to find this gradient. This gradient is going to be the difference in y, so 1 minus 2 is 1 plus 2, which is 3, divided by 7 minus 1, which is 6. So the gradient is 1/2. And then it passed point C, so the line CD is going to have equation y minus the y of the point, so y minus 4 is going to be the gradient 1/2 x minus the x of the point, so x minus 3. We could potentially leave it like this, or we can expand the bracket, multiply everything by 2, and it will look slightly better. But if they don't ask how we have to write it, or write in a particular way, because sometimes they do, it's okay how you leave it. So 2y is going to be x plus 5. And this is the equation of the line. Then next thing it says, show that point D has coordinates -1, 2. This point. So this point is going to be the intersection between this line that we have already here and this line. So what we're going to do is to find the equation of this line. The equation of this line has negative and reciprocal. So the gradient of this line is negative or reciprocal of this one. So the gradient of, this is going to call L2, so M2 is going to be, if this one was 1/2, this is going to be -2. And now it passed the point A. So the line 2, let's call it line 2, is going to be y minus -2. So I'm using this point. Y minus -2 is y plus 2. M is -2. X minus the x of the point. Yeah. So y plus 2 is -2x plus 2, or y plus 2x 0, yeah, because the 2's are cancelled. So we have this line, and now we say the intersection between this line and the line that we wrote before, so the 2y is x plus 5. So this line, which is this line, the intersection of these two lines is going to be D. And we just solve simultaneous equations. It's really up to you how you write them. So for example, from here, y is -2x, so I can substitute in the other one, and I have 2y is going to be x plus 5. So I have -4x is x plus 5, which means that -5x is 5, and x is -1. So this is x, and I need to find the coordinate of y, so I can use this one, for example. So when x is -1, I have -2 times -1, +2. So y is +2. So the coordinates of D are -1, 2. And that's they were given anyway, so if we make a mistake, we can just work it out. Then find the sum of the length of AB and CD in a simplified short form. AB, and I'm going to write the coordinates here. So A is 1 minus 2, just we have them handy. 1 minus 2. B is 7, 1, and C was 3, 4, and the that we just found is -1, 2, no? -1, 2. Yeah, so now we are going to find AB. The distance AB is the square root of the difference in x, so 7 minus 1, 6 squared, plus the difference in y. 1 minus -2 is 3 squared. So this is 36 plus 9, which is root 45. 45 is 9 times 5, so we can get the 3 outside and have 3 root 5. And the distance between C and D, so CD is square root of the difference in x. So -1 minus 3 is -4, so -4 squared, plus 2 minus 4 is -2 squared. So we have 16 plus 4, 20, root 20, and 20 is 4 times 5, so we can get 2 outside root 5. And they ask the sum, so not the distances, but the sum. So the sum is going to be 3 root 5 plus 2 root 5 is 5 root 5. Yeah, that's the distance, the sum of the distance. And then finally, and they say hence, so please use the information that you had before. Find the area of the trapezium A, B, C, D. So the area of this trapezium is going to be the sum of the parallel sides, that's precisely what we just found, divided by 2 and multiply by the distance between them. And the distance between them is AD. So to find the area, I would need to find AD first. Yeah. So first, AD is going to be square root difference of in x, so -1, for example, -2 squared, plus 2 minus -2 is 4 squared. So I have again root 20, which is 2 root 5. So the area of the trapezium is going to be the sum of the parallel sides, which is 5 root 5, divided by 2, and then multiply by the distance between them. We can cancel the 2, and then we have root 5 times root 5 is 5, times this 5, 25. So the area is 25. And we don't have units, so we can just leave 25. Yeah? That's all with this question.